Hey everyone, so today we are going to talk about probability mass function, that is PMF, and cumulative distribution function, abbreviation is CDF. This is the notation for PMF and this is the notation for CDF. Okay, now see, in last lecture we talked about random variables, and among them one of the type was discrete random variable. So today we are going to focus only on discrete random variable. So when you have a random variable, and if you want to study the probability distribution of that random variable, then these two things comes into the picture. Okay, so again let's recall, if x is a function from your sample space to real numbers, then your x is a random variable, and we are concentrating on discrete random variable. So suppose the range set of x is either finite or countable in number. So okay, so suppose range set is x1, x2, x3 and so on. This is a discrete outcome. So your x is a discrete random variable. Now the question is, what is the probability that the random variable x will take the value x1? This is nothing but your PMF, probability mass function. Okay, or probability discrete function as well sometimes, or probability frequency function sometimes. So this is what the question is, and that's what we are going to address in this lecture. Similarly, what is the probability that the random variable is taking the value x2 and so on? What is the probability that random variable takes the value x3 and so on? Okay, so this is what we are going to see today. Now before going into much more detail, let me try to take one example so that you will understand what I'm trying to say. Now suppose this is your sample space. So what is the random experiment? You have fair coins and you are just tossing it 3 times. Okay, so what is the what is the sample space? This either will get all 3 heads or HHT and all these things. This is one of the simplest example. Now question is, now see, I need to define a random variable first of all. So let me define a random variable. X of omega is nothing but number of heads that occur. Number of heads that occur in this sample space. Okay, so this is a function from sample space to real number. Now what is the range set of x? So either there will be no heads, because this can come, or there will be 1 head or 2 heads or 3 heads. These are all the possible outcomes for the random variable that we have defined. Okay, now this is finite in number, so this is a discrete random variable. Okay, now question is, what is the probability that the random variable x will take the value 0? Or another notation is p random variable of 0. See this, now this is acting as a variable. This will act as a variable to this function, and that's what I gave you one of the motivation, that why the name random variable. Okay, so p x of 0. Now this is nothing but what is the probability that no heads occur. X is equal to 0 means what? No heads is occurring. No head is occurring. But what is the probability? Now it's a fair dice, so it's a fair coin. So therefore there are 8 possibilities total, and probability that no head is occurring is 1 by 8, because TTT, that's the only case when no head will appear. What is the probability that the random variable x will take the value 1? That means probability that only 1 head occurs. So we know that this will be mapped to 1, this is mapped to 1, and this is mapped to 1 under this function x. And what is the probability? It is 3 by 8. What is the probability that the random variable takes the value 2? That means 2 heads. These 3 outcomes will map to 2 under this function, which is again 3 by 8. And probability that the random variable takes the value 3 is again 1 by 8. So this is the probability distribution for this discrete random variable, and this is nothing but your PMF. That's all. I will state the definition and some nice properties, but yeah, if I want to say in a simple language, it is nothing but the probability distribution for the given random variable. Okay, now one thing you can observe, everything are positive because they are the probabilities, so it's always greater equals 0. If you sum up the probabilities, what will be the answer? 1 by 8 plus 3 by 8 plus 1 by 8 plus 3 by 8. You sum it up, you get 1 as an answer. Why that is happening? Now let me try to explain you that part. Okay, now let me try to give you a justification that why the sum of the probabilities was 1. Okay, now see, it depends on the textbook you are using. Some people in the definition itself of PMF says that the sum of the probabilities should be 1. But in this scenario, it will come out to be 1. Let's try to see that why. And that's why some authors don't include that in the definition. Okay, so you have this discrete range set, probability that x equal to x1, that was the question. Like you can relate with the earlier example, probability that x will take the value 0. So ultimately, see, now what is my event? See, here also indirectly we are finding the probability of some event only, but that's a different event. Now what kind of event we are taking? So here, what is my A? I am looking into those outcomes such that whose value is x1 under the random variable x. Let me take B, or let me call this as A1, A2, all those outcomes in the sample space whose image under x is x2. Okay, so you have this sample space. I'm just partitioning this A1, A2, A3, A4, A5, A6 and so on, such that under x your all the elements over here is mapping to x1, all the elements over here is mapping to x2 and so on. Okay, is this a disjoint partition? That's what one can ask. Is this a disjoint partition? Answer is yes. Why so? See, can you have a common element in the intersection? Answer is no. Suppose your omega is in the intersection. That means what? Omega is in A1. If omega is in A1, means what is x of omega? It is x1. Omega is in A2. That means what is x of omega? It is x2. So you are having an element in the sample space which are having two outcomes, x1 and x2. Is that possible? No, because your x is a random variable. It means it's a function. And when you say something is a function, for every input you should have a unique output. You cannot have a two output. Then it is no more a function. Then it is something called as relation. But okay, we are not going into that. A function, an element cannot have two distinct output. So therefore this is not possible. Therefore the intersection is empty. In general, if I take AI, AJ, where I and J are not equal, we get that the intersection is empty. Okay, and now comes our main part, that why the sum of the probabilities is 1. Now we know that our 1 is nothing but probability of the complete sample space. Now I am writing my sample space as A1 union A2 union so on. Right? Now there, what is A1? All those outcomes whose image under x is x1. All those outcomes whose image under x is x2 and so on. Just now we saw that they are disjoint. So by definition of probability, this is summation of probabilities of AIs. I is from 1 to n. There is nothing but summation I from 1 to n. Probabilities of AIs. That means I am looking for the probabilities that the random variable is taking the value x1. That means probability that random variable is taking the value xi. Or another notation is summation px of xi. So therefore sum of the probabilities will always be 1. Okay, so I am stressing on, I thought of including this point because one student asked me that in Walpole book of statistics, he include this in the definition, whereas when he was referring some online notes there, this was not taken as a definition. So I thought it's better to stress this point. Okay, so I hope this point is clear. Okay, so let us see the definition. So function f is called as a probability mass function, or some people also like to call it as an ordered pair x comma f of x. That this is a PMF. Okay, they would like to mention this is x means the range set in the discrete random variable x, capital X, and you write this output over here. Okay, so what is this? It's a function. What is the output if x is that output of the random variable capital X? What is f of x? Is output is the probability that the random variable is taking the value x. Okay, so it's always a good habit to write 1 comma 1 by 8, or I would say 0 comma 1 by 8, like in earlier case. The probability that the random variable is taking the value 0 is 1 by 8. Probability that random variable is taking the value 1 is 3 by 8. 2 comma 3 by 8 and 3 comma 1 by 8. So it's always good habit to write the x and the probability it is taking. Okay, so that is another way of writing. So a function, so this is the main thing. Many author will only say this point. So f is the probability mass function such that it is value of f at given x is nothing but the probability of random variable at that point x. So that's why the probability name, okay, because the function is taking the probability value. Now no need to state this definition because obviously we are taking the probabilities, therefore f of x is always greater or equal 0. Why equal to 0? Because some author also say minus infinity less than x less than infinity. They write this is for all x. So for those x which are in the range, for example here the range was 0, 1, 2, 3. For them we have the probability, and for other x like 4, 5, 6, 7, minus 1, minus 2 and so on, for them you define the output as equal to 0. Okay, therefore if you see this term over the here, don't get confused. Don't think, oh, but if I have the finite outcome, then what will be the function? In that scenario, the numbers which are not here in the range, for that you define the function as 0. Okay, this I already told you that sum of the probabilities x belongs to x. Now what does this mean? X belongs to x as in x is in the range set of the x, but this is a notation people use. Okay, they don't say x belongs to range set of x. Some people do say, but this is the common notation. Okay, so this also I told you that the sum of the probability should be 1. So that's why you will either see only this as a part of a definition or the complete 3 points, but that's okay, whichever book you are referring, refer that. Okay, so that's what you mean by probability mass function. So this is one function to observe or to play with the probability distribution for the given random variable. Okay, so this is one way to play with the probability distribution for discrete random variable. What is another way to play with the probability distribution for a discrete random variable? It is CDF, cumulative distribution function. Okay, so here we denote by capital F of x. This was small f, probability mass function, and this is capital F. And this is nothing but probability that the random variable takes all the values less equal, cumulative, the name itself says. Okay, so this is at the particular point, this is at a point n less equal that. Okay, so this is nothing but, suppose if this is my x3, suppose, so you take probability at x equal to x1 plus probability at x equal to x2 plus probability at x equal to x3. So you sum it up all. That is what your CDF is. Okay, now let me take 2 examples, and along with those examples I will explain you some of the nice properties as well. So here is a question. You have a shipment of 7 TV sets, okay, and among those 7, 2 are defective. A hotel makes a random purchase of 3 sets, okay, and if x is the number of the defective sets purchased by the hotel, I want to find the probability distribution of x. Okay, now obviously this is your x is a discrete random variable. So what will be the range set? So either there will be a 0 defective sets or 1 or 2, because in those 7 only 2 are defective. Okay, and they are going to take 3. So the range set of x will be either 0, 1 and 2. Now the question, what is the probability that the random variable x will take the value 0? That means probability that no defective TV sets are taken by the hotel. Okay, now there are 7 and I have to choose 3. So total possibilities is 7, choose 3. Out of 7, 2 are defective, that means 5 are not defective, and here I am looking for no defective. So I will be choosing the 3 from 5 TV sets. So 5, choose 3. Okay, and I have done the calculation, so answer comes out to be 2 by 7. Probability that the random variable x will take the value 1, that means probability that among those 3 purchased TV sets, 1 is defective. So total is 7, choose 3, 1 is defective. Now out of 2, so 2 choose 1, and out of 5, 5 choose 2, because 1 is defective, 2 are not defective. Okay, and the answer I have written is 4 by 7. Okay, yeah, 4 by 7. And the third scenario is probability that the random variable will take the value 2. So here also you have 7, choose 3, 2 defective, so both 2C2, and from 5 which are not defective, 5 choose 1. So this is what my answer, and here in this case I have solved, answer is 1 by 7. Okay, now the first observation, What is 2 by 7 plus 4 by 7 plus 1 by 7? You add it up, your answer will come out to be 1. Okay, so that's the first thing. Now, this is one way to write. Another way to write is, in general, one can also write this. Okay, so probability of x. See, when you're writing a code or something, you always define a function where x is a variable, right? Like a bank operator. What does he do? Like if you want to calculate the interest I'll be getting after 3 years, he will enter the principal amount, he will enter the rate of interest, number of years, right? He will just click enter and he will get the output. What is happening at the back end? The software developer must have put that compound interest formula, but obviously the man sitting at the front end, he doesn't know that. Similarly, now when you put this in the, if you want to put as a formula, what is the formula that one can use? Here, what is changing? This is changing. So see, at the bottom it is 7C3. Okay, now here 2 choose x into 5 choose, what this will be? 5 minus x, or what that will be? So I have to choose 3, no sorry, so 3 minus x. When my x is 0, so 2C0 is 1 and this is 5 choose 3. When my x is 1, so 2 choose 1, 5 choose 2. And when x is 2, 2 choose 2, 5 choose 1. So this is a general formula. Okay, so you can define like this, and 0 everywhere. So this is when my x is 0, 1, 2 and when otherwise. So some people also expect answer in this way, that you give a general formula for the probability mass function. So yeah, I hope this is clear. Actually you can generalize bit more. You want to more generalize. So suppose, let me just give a try. I have not prepared for this. So if n is the total number of TV sets, okay, so n is the total number of TV sets, and I have to choose 3. So in general, if I want to choose m number of TV sets, so mm, okay, and there are 2 defective and 5 are non-defective. So suppose if I am saying here my what notation, if p are the defective, then how many are non-defective? N minus p. So this is the best generalized formula one can have. Once you put capital N, small m, small p and x, you get the answer. So now it can be anything, need not be 7, need not be 3. Okay, so one has to take care while writing the code that m has to be less than n. If it is greater than n, then what, it should be 0 and all, or it will give you an error. But yeah, this is what in general a formula one can write. Okay, good. So that was the formulatic part. People also try to see this graphically. Okay, graphically as in what? Now see, what was my input? 0, 1 and 2. For 0, so this is my input, small x, or the range set of x, and output is the probability. So 1 is 2 by 7, 4 by 7 and 1 by 7. So I think 2 by 7 will be somewhere here, 4 by 7 and 1 by 7. So this is a graphical representation of a probability distribution. So these are my probabilities and these are my random variables. I mean the range set. Okay. So this is one way of drawing the diagram. Another way is the histogram. People also try to draw the histogram out of this. What is that? You just take the midpoints over here and you draw like this. So this is the histogram. And what is the good point about this? The areas of this is nothing but the probabilities. Because see, what is the length? Length is 1. So your height is nothing but the probability. So area of this rectangle is nothing but the probability that the random variable will take the value 0. Area of this is nothing but the 1 into the length. Length is nothing but the probability. So area of this rectangle is probability that the random variable will take the value 1. Okay, so people also represent this in a graphical way. And the last one is the tabular form. Okay, so your x, and here you have p of x. What is my x? 0, 1, 2. And what was the answer? I think 2 by 7, 4 by 7, 1 by 7. So this is called as the probability distribution table. So in this one example, I have told you how to write down the formula in general if they ask you. Not always possible, but many times yes, it is possible. If they ask you to draw the table, this is the table that you are going to draw. and if they ask you to draw the diagram, then you know those two diagrams. Okay, now this was about the probability mass function. One can also play with the probability distribution, CDF, cumulative distribution function. So let me play with that in the next example. So here is the last example. You have to find the probability for the number of, I think my hairstyle has gone bad, but it's okay. Okay, so find the probability for the number of jazz CDs when 4 CDs are selected from a collection consisting of 5 jazz, 2 classical and 3 rock CDs. Okay, so what will be your small x? Be the number of jazz CDs collected. So either it will be 0, 1, 2, 3 or 4. That will be the range set. So probability that the random variable will take the value 0. That means no jazz CD is selected. How many total CDs are there? 5 plus 2 plus 3, 10. And I have to select 4. So 10 choose 4. Now no jazz CDs are selected. So 2 and 3, 5. So out of 5, I have to choose 4. Now this I have not solved. So you can just solve it up. Okay. Probability that x is taking the value 1. So 10 choose 4. From this 5, I can choose 1. And from remaining 5, I will choose 3. Okay. Now you can write down in general, or you can just pause the video and think what will be the general formula. Okay, so you can pause it if you wish. So here it will be 10 choose 4, and here it will be 5 choose x into 5 choose 4 minus x, and x can be 0, 1, 2, 3 and 4. For other values you define it as to be 0. This is your PMF. And one can again generalize like we did the earlier problem. You can call this as capital N, this is your small n, this is, you can say, P and capital N minus P. Okay, so one can write down this kind of formula. Now once you are done, what you can do is you can just pause, and I hope you have pen paper with you. Just find out the probabilities for each of them. Draw the probability distribution table, draw the graph, and also draw the histogram for this. Okay, now once you are done with this, see, now people can also ask you what is capital F of 2. So what this will be? F of 0, small f of 0, or you can say probability that x is taking the value 0 plus probability that x is taking the value 1 plus probability that x is taking the value 2. So just sum it up, you get this answer. Okay. If someone asks you what is probability that your x is taking the value between here, so what this will be? That means this is nothing but probability x is less equal to minus probability x is less than 1, right? But what is this? You can take this as capital F of 2 minus what is this? Capital F of 1, and when you solve this, you get the answer. Okay, so such kind of questions people usually play with. So this subtraction will help you to find in between the probabilities. Okay, like probability of 0 less equal x less equal 7. So capital F of 7 minus capital F of 0, and once you have those values, you can easily do the subtraction. So yeah, I think I covered most of it. In future, if I think something is missing, I will record a separate lecture. And if you feel that something is missed about this discrete random variable case, PMF or CDF, you can post in the comment section. So yeah, I hope it is clear. If you don't have any doubt, then do not forget to like, share and subscribe. If you have any doubt, then you can ask me in the comment section. Thank you.